Okay, this is lesson 6.1, translations. And we're learning to transform figures using a translation. We've already learned about dilations, which transform figures by changing the size but not the shape of a figure. A transformation is just a change in the size or position of a figure. We've also said that it changes the size but not the shape of a figure. The shape never changes. A translation is just a transformation in which a figure slides to a new position. So you might just remember a translation as a slide. It's going to slide to a new position. It's going to keep its orientation, its direction. It's just going to slide to a new place. Notice this note. Incongruent transformations, which is what a translation is, also a reflection and a rotation are also congruent transformations. The figures change position, but the size and shape do not change. Size only changes in dilations. Shape never changes in a transformation. In example 1a, we're going to graph the translation of triangle ABC, 2 units right and 3 units down. We have two methods we could use to figure this out. One is we could actually use the coordinate plane and actually slide the translation, or slide this triangle 2 units right and 3 units down. So we're going to try that method first. We're going to take each point and we're going to go 2 units right and 3 units down. So I'm going to start here at point A, and I'm going to count 2 units right, 1, 2, and 3 units down, 1, 2, 3. Do remember when you are counting on a coordinate plane, it's just the number of blocks that it moves over. So notice that A moved 2 blocks right and 3 blocks down to get to A prime, the new coordinate. Now for point B, it starts here. We're going to go 2 units right, 1, 2, 3 units down, 1, 2, 3. So we've got B prime. And then for point C, it starts here. We're going to go 2 units right, 1, 2, 3 units down, 1, 2, 3. And so I plot point C prime here. And I just connect my points. Notice that I have gotten the same triangle, and all I did was I counted my units to the right and down to move it. So it was a slide as a translation. Our second method is to actually use a rule to find the new ordered pairs. X adds the number moving right and subtracts the number moving left. So since it went 2 units right, going to the right on the coordinate plane, notice it goes more positive. So we take the x value and we add 2. So we've got x plus 2. And then y is going up and down. It adds the number moving up and subtracts the number moving down. So it's 3 units down, so we'll take the y value and subtract 3. So I'm going to write these ordered pairs. I have A, which started at -6, 5. Point B started at -6, 0. And point C started at -1, 0. And then I'm going to do this transformation for each of these to get A prime, B prime, and C prime. For A prime, we take the x coordinate -6 and add 2. -6 plus 2 is -4. Then we take the y coordinate 5 and subtract 3. 5 minus 3 is 2. So we get that A prime is -4, positive 2. Notice that it's in the same position that we graphed using the coordinate plane. B prime, we take the x coordinate -6, add 2, and we get -4. We take the y coordinate 0, subtract 3, and we get -3. Notice that B prime -4, -3 is the same point we plotted when we graphed it. And then C prime, we take the x value, -1, and add 2. and that gives us positive 1. And we take the y value 0, subtract 3, that gives us negative 3. So we get 1, negative 3, and that's the same point we plotted before. So we've got our ordered pairs by graphing, and then the second method by using a rule. Example 1b, we're going to graph the translation of triangle DEF, 4 units left and 2 units up. The first method, once again, we're going to just count on the coordinate plane. I'm going to take point D, and I'm going to go 4 units left, 1, 2, 3, 4, and 2 units up, 1, 2, plot my point. Take point D, go 4 units left, 1, 2, 3, 4, 2 units up, 1, 2, plot a point. For F, I'm going to go 4 units left, 1, 2, 3, 4, 2 units up, 1, 2, plot a point. And so I connect the dots. And we've got triangle D prime, E prime, F prime. The second method, we're using the rule. 4 units left means that x goes left, because when you go left on the coordinate plane, it gets more negative. And then 2 units up, so y goes up 2, it adds 2, because on the coordinate plane, as you go up, the y's increase. So I'm going to start with my ordered pairs. These were D, E, F, so D was 4, 4, E was 1, negative 2, and F was 2, 0. Sorry, it was not 2, 0. F was 6, negative 2. And so then we go through and we find what our new ordered pairs would be. And I'm just going to follow the rule. Sometimes it's easiest if I go through and I do all my x's first and then my y's, because they have 2 different rules. So I think I'm going to start with my x's. I'm going to take every x and subtract 4. This x4 minus 4 is 0. This x1 minus 4 is negative 3. This x6 minus 4 is 2. And then I'll go through and find my y's. Y plus 2, so this y4 plus 2 is 6. This y negative 2 plus 2 is 0. And this y negative 2 plus 2 is 0. And so I get these ordered pairs. I can check and make sure I'm right. D prime was 0, 6. E prime was negative 3, 0. And F prime was 2, 0. And it did work. Example 2a, we're going to name a rule for the translation of triangle XYZ to triangle X prime, Y prime, Z prime. So we have learned how to use a rule to perform a translation, but now we're actually going to name the rule. So to do that, we're just going to find the change. What happened to this triangle to get to the new triangle X prime, Y prime, Z prime? So here's what we notice. We could count and see what it did going from left or right. From X to X prime, it moved left. So let's see, it moved left how many places? From X, let's start counting. 1, 2, 3, 4, 5, 6, 7 units left. And then did it go up or down? It went up 1 unit. So we have a rule that we can write for that. We can say from our pre-image xy that x went left 7 units, so that value subtracted 7, because when we go left on this x coordinate, it becomes more negative. And then y went up 1 unit, so we're going to add 1 to y, because when we go up on the coordinate plane, it becomes more positive. And we've written our rule. Example 2b, once again, we're going to name a rule. So let's see what happened from, let's say, from K to K prime. So first we see if it went left or right, because we're seeing what the change in X was, and it went right. So we go 1, 2, 3, 4, 5, 6, 7, 8 places right. So it went right 8 units, or 8 units right. And then whether it went up or down, and it went up 1, 2, 3 units. So we'll say and 3 units up. And now we just name that rule. So we always start with the order pair x, y, and right is going more positive. So we're going to say x plus 8, and up is going more positive. So we say y plus 3, and we've named our rule. Okay, last I have just a couple questions. In a translation, do the angle measures change? Well, whatever angle this angle J was right here, J prime is obviously the same size. Whatever angle K was right here, K prime is the same size. And whatever angle L was right here, L prime is also the same size. So do the angle measures change if the figure just slides to a new place? No. They stay the same. And they will always stay the same in a transformation. Angles never change in transformations. That's very important to know because you'll have questions that might look a lot more difficult than they are asking about angle measures, and if you know that they don't change, then that makes the problems very simple to answer. The next question, do the lengths of the sides change? Well, if I look at these sides here from J to K, and I know it just slid over to get J prime, K prime, did that side get longer or shorter, or did it stay the same? It would have to have stayed the same. From K to L, going from K prime to L prime, it also stayed the same. And from J to L, which we can actually count, was 5 units wide. And from J prime to L prime, we can also count, was 5 units wide. It also stayed the same. So do the lengths of the sides change? No. Lengths stay the same in congruent transformations. The only type of transformation where the side lengths change would be a dilation.